Alright guys, so this is a video for several of you. I noticed that we needed a review on solving equations in general, and the thing that I want to worry about right now, just to kind of get through this unit on geometry, which is not really about solving equations, but is sometimes necessary, is just how to solve two-step equations, because that's usually going to be about the biggest one that you're going to need to know. So there are 5 reminders that I want to give you guys to solving two-step equations, and they are reminders. This is not step-by-step how to do it. They are not instructions. So you don't start with number 1 and then go to 2 and 3 and 4 and 5. You just need to remember these things as you do these, all right? So first and foremost, remember that you are isolating the variable, so don't mess with the variable. Don't add the variable, subtract the variable, divide the variable, multiply the variable. Don't do any of that stuff. Just leave the variable alone, all right? Now there is one exception to this that I'll get on later, but after you have it in a form that you need it in, and I'll tell you what that's in a second, just don't mess with it. Don't add, subtract, multiply, divide the variable, all right? Number 2, make sure that you perform all actions to both sides. It is called an equation. You guys might be able to make out the word equal in there. So if you subtract 8 from one side, you will have to subtract 8 from the other. Otherwise, it's not an equation anymore because both sides aren't equal. So make sure that you perform all actions to both sides. Number 3, you need all the variables on one side. I'm supposed to say 1. Come on now. Come on, Trey. All right, 1. So if they are not on one side, you need to move the variables so that they are on one side. And I'll give you an example of what I mean by that. All right, 4 is combined like terms, and that kind of goes along with this one, so I'll talk about that later. And then 5 is reverse PEMDAS. So that one is how we're going to remember how to solve two-step equations, all right? Normally, we would go through the order of operations, parentheses, exponents, and then multiplication, division, and then addition, subtraction. Well, when we solve equations, are going to take care of it in reverse order. All right, so we're going to take care of the addition and subtraction first, and then the multiplication and division. Okay, so I'm going to give you guys a few examples. There are 4 examples I want to give, and they're going to go through all of the reminders that I just gave, all right? So first, let's look at this one. 8x plus 13 equals 61. So remember that anytime that you see a equation with only one variable, that means that there is only one answer, all right? This is not a line or anything. This is just one number. So that makes our job a little easier. So first, like I said, we're gonna start with reverse PEMDAS, and we know that x is being multiplied by 8 and x is being added by 13. And that's the only 2 things that are keeping it from being alone. And we want to remember that we are isolating the variable, so we're not going to mess with it. We are just going to leave it alone and take care of this 8 and this 13. All right, so first, like I said, we're going to do reverse PEMDAS. So we're going to take care of addition and subtraction first. It's being added by 13, so we're going to subtract 13 from both sides because that's the opposite of adding 13. So this side will be 13 minus 13, which will cancel to be 0. And 61 minus 13, if you plug in a calculator, you'll find is 48. So now this side is equal to 48. This side, all that's left is this 8x down here because we didn't do anything to that. So I'm going to move that on down and keep going, all right? Now 8x equals 48. So like I said, this 8x means that 8 is being multiplied by x. And we don't want to mess with the x, we want to mess with the 8 because we are isolating the x. So to isolate the x, we're going to do the opposite of multiplying by 8, which is dividing by 8. So we're going to divide by 8 on this side, divide by 8 on this side. And again, remember that I am performing all actions to both sides because you cannot just divide by 8 on one side, you have to divide by 8 on the other side as well. So then this will cancel because 8 divided by 8 is 1, and 1 times x is just x, so you might as well not even write it. So now all that's left over here is x, which is what we want in the first place. We have now isolated the x. And then 48 divided by 8 is 6. So in this problem, x equals 6. And I always put a box around my final answer, and I'd really appreciate if some of you started doing that too, because sometimes you guys have a lot of work, but I can't find your answer. So just put a box around your final answer for me. That makes my life easier. All right, next thing, let's try one just a little bit like it. But this one has a few little tricks, all right? But it's the same deal, all right? It's just a number being multiplied by the variable, and then added or subtracted, and then an equal sign with another number. So there's nothing special about this one. It's in the form that you want, and I'll talk about that in a second. It'll be easier to see what I mean by the form that you want when you see one that's not in the form you want. But right now this one is. This one is in the form that we want. So we're going to take care of addition and subtraction first, like I said. So that's going to be this minus 54. So now I like to think of this as negative 54, all right? Instead of minus a whole number 54, this is actually, to me, negative 54. So the opposite of subtracting by 54, or the opposite of negative 54, is positive 54. So we're going to add 54 to both sides, like this. And then we're going to cancel right here, because negative 54 plus 54 is 0. And then negative 26 plus 54, if you plug that in a calculator, you will get 28. All right, and then the only thing left over here is this 4x, because we didn't mess with that, we just canceled this. So now you have 4x equals 28. Then you divide by 4, because the opposite of multiplying by 4, which is what 4x means, is dividing by 4. So we're going to divide this by 4, divide this by 4. 4 divided by 4 cancels, because that's just 1. So then you have x over here, and then 28 divided by 4 is 7. So then you get x equals 7. And that's that, all right? Those two are very simple. They're in the form that you want to start off with, and all you have to do is 2 steps. That's why it's called two-step equations. You have to first take care of the addition, subtraction, and then take care of the multiplication, division. So now we're going to go to some that are not in the form that we want. And it makes it look like they aren't two-step equations, but they still are. You just have to get it, do a little work to get it in the form that you need it to be in, all right? So we're going to work with this one first. So this one, it says negative 2x plus 8 equals x minus, or x plus 2, all right? So this one, I'm going to go back to this reminder right here, which was you need all the variables on one side, all right? Right now, you can see that you have an x over here and an x over here, and that's not going to work for us, all right? We need them all to be in one side. So how I'm going to take care of this is just by subtracting this one x over here. So I'm going to subtract this x over here and then do the same thing over here, because you still have to remember that you are going to perform all actions to both sides. So we're going to subtract this x and move it over here. So x minus x is going to cancel, because anything minus itself is 0. And then negative 2x minus x is going to be negative 3x. And then you still have this plus 8, so that's still going to come down. And then this equals, and then everything that's left over here is this 2. So it's just going to be positive 2 over here. So now we have negative 3x plus 8 equals 2. And now you have it in the form that you want, all right? So we had to go through an extra step, I guess. We need to get all the variables on one side, but now we're here, and we have it how we want it, and we just go through reverse PEMDAS. So the first thing you need to take care of is the addition subtraction, and that's the plus 8 right here. So we're going to subtract 8 from both sides, because the opposite of adding 8 is subtracting 8. So 8 minus 8 is 0. That cancels. Move this negative 3x down. And then 2 minus 8 is negative 6. All right, and then now you just have negative 3 being multiplied by x. The opposite of multiplying by negative 3 is dividing by negative 3. So this is going to be negative 3 divided by negative 3. Anything over itself is 1, so that's going to cancel. And then you do the same thing to the other side. And 6 divided by 3 is 2, and a negative divided by a negative is a positive, so it's actually going to be x equals positive 2. And that would be your answer for this one. So like I said, this one was a reminder. You need this reminder right here, number 3, that you need all the variables on one side. And if it's not already like that, you're going to have to do some work to get it like that. And then the last example I want to do is over here. And this one is, again, this one is not in the form that you want it in. It's in a different form. It's being grouped, all right? And maybe when this person made this equation, these things actually meant something. Like when if you guys have watched, or you will eventually watch the postulate video, the angle addition postulate video, we end up setting up this equation right here to solve this. So maybe it's like that, where in the beginning, you know, this was the measure of angle WLA, and this was the angle measure of angle ALK, and we were told in the problem that that is x plus 78 and x plus 41. So in this context, we needed it like this because it made more sense. But now it's like this, and we need to get out of this because that's not how we need it to solve. So first, you need to realize that these parentheses are not doing anything other than grouping them. They are not being multiplied. There's no 2's or x's or anything else on the outside of those, so we can just take them away. So we're going to do that. We're just going to rewrite the entire thing, but without the parentheses, because nothing special about these parentheses. So now I have this rewritten. Next thing I want to do is I want to address this little thing right here. So it says plus -4. And just so you guys know, like in multiplication, a positive and a negative is a negative. And that's why I say I like to think of these as just -4. So I'm going to rewrite it again. But this time I'm going to rewrite it how I think of this, which is just, instead of plus -4, I'm going to just say -4. And then that. All right, so now I have that taken care of, and it doesn't look at all janky. And now I can move on to combining like terms, all right? And that is reminder number 4, all right? Combine like terms. So although all of your variables are on one side, you still need to combine them, all right? So we have like terms here. Just so we know, a like term is something that has the same variable or lack of, all right? So for instance, I'll do these first. This 70 and this -4 here are like terms because they are both constants, meaning they have no variables with them. So I'm going to take this and this first, and then 70 minus 4 is the problem you're dealing with. So positive 70 combined with -4 is 66, because 70 minus 4 is 66. All right, and then these are like terms, right? These are both just x terms, so it's the same variable. So then you're just doing 12 plus 9, all right? So 12x plus 9x is 21x. All right, and this is positive 66, so we're just going to put a plus sign right here, and that's how you combine like terms. And then this still all has to equal this -39. We just combine like terms. And again, now it is in the form that you want it in. It's just the variable with a coefficient. That's what that number out front is called, that you're multiplying the x by. That's called a coefficient. So you have a variable, a coefficient, and a constant. And that is the basic form of a two-step equation. And now we're there, so we can just do reverse PEMDAS. So we're going to subtract 66. This will cancel. -39, find this, -39, where is it? -39 minus 66 will be -105. And then over here you have this 21x coming down. So you have this, and then you're going to divide. To take care of the multiplication by 21, you're going to do the opposite, which is division by 21. Some of you guys might notice that this looks like a fraction. That's because it is a fraction. Fractions and division are essentially the same thing. Just like I could write 21 divided by 21 like this. I could say 21 divided by 21, or I could write it like this, 21 divided by 21. I can also write it like this as a fraction, right? All these 21 divided by 21 are the same thing, just so you guys know, right? But this cancels because 21 divided by 21 is 1. So over here you just have the x, and then over here you have 105 divided by 21, which is 5. And then it's a negative divided by a positive, so that's going to be a negative. So it's going to be negative 5. And that's going to be your answer. But yeah, that's all you guys really need to remember about how to solve two-step equations. Sometimes it might be janky, like these, where they're not in the right form, and you just need to remember to get them in the right form. Sometimes you'll have to combine like terms. Sometimes you might have to move variables all to one side. Sometimes you might have to do both. But as long as you remember my reminders right here, which again are to remember that you're isolating the variable, so don't mess with it. Don't add, subtract, multiply, divide the variable. Make sure that you perform all the actions to both sides. You need all the variables on one side. You combine like terms, and you're doing reverse PEMDAS. As you remember those 5 things, you should be fine.